So let's look at halogenation of alkynes. If we add an excess of our halogen, we'll get R, C, A, R, and we'll get halogens everywhere. We'll get it added twice at 60 to 70%. Now, if we just add one equivalent, then we'll only get one addition, and we'll get a double bond will remain. Get R, and those will be X's, and we'll also get put our halogens in there. We can get halogens across from each other, or we can get them on the same side. This will be our major, and this will be the minor. Ozonolysis. This is ozone followed by water, and then it cleaves to make two carboxylic acids. So we have our starting product, our alkyne. And what this is going to do, we're going to add ozone, and we'll follow it with water. And what this is going to do is break it right here, right at that where that triple bond is, and make two carboxylic acids. So the first carboxylic acid will be R, carbon. The second carboxylic acid will be, and have the second R group on it. If the alkyne is terminal, then you get one carboxylic acid and carbon dioxide. So let's draw the major products when each one is treated with ozone followed by water. So first, we're going to break it right here. So we'll have two carbons. The second carbon here is going to have the carboxylic acid on it. The second molecule has 1, 2, 3 with the methyl group off the 2. So we'll have, and this one will have carboxylic acid. And we have a methyl group off the second carbon, so like that. The B, remember, we're going to break it right here. This side will give us carbon dioxide. Because it's terminal, this carbon right here ends up being in this carbon dioxide. This one is 1, 2, 3, 4 carbons long, and it'll be a carboxylic acid. Here, we're going to, break it right here. This will be 1, 2, 3. Over here we'll have 1, and then this cyclopentane. So we'll get, oh, I left it on the pencil. Okay, we can do that. And the other side will be cyclopentane. It just has a single carbon off of it. the carboxylic acid is formed.